You see a new high-rise going up downtown, and it seems like a new floor is added every single week. How is that even possible? Are they pouring concrete that fast? The secret often isn't the speed of the on-site crew. It's that the concrete floor was made weeks ago in a factory miles away. The mass production of concrete floors is one of the biggest efficiency breakthroughs in modern construction, turning a wet, slow, and weather-dependent site activity into a precise, controlled, and rapid assembly process. In this video, we're going inside a precast concrete plant to see how floors are manufactured on an industrial scale. We'll follow the journey of a hollow core plank from a pile of raw materials to a finished, structural component ready to be lifted into place by a crane in a matter of minutes. This is the future of building, and it's happening right now. The mass production process begins long before any concrete is mixed, with the most critical phase, design and detailing. In a traditional cast-in-place floor, engineers design a generic slab, and crews figure out the formwork on site. In the precast world, every single plank or double T is a unique, engineered component. Using BIM software, designers create a detailed shop drawing for every piece, specifying its exact length, width, the location of every strand of pre-stressing steel, and the placement of all lifting inserts and embeds for connections. This digital model is sent directly to the factory's production line. A pro tip from precast engineers: the most common point of failure isn't the concrete strength, but incorrect placement of lifting inserts. Getting the design and detailing 100% correct here is non-negotiable, as a single error can ripple through the entire production run and cause costly delays on site. Now let's step onto the factory floor, specifically for the most common mass-produced floor, the hollow core plank. The production line is a long steel casting bed, often hundreds of meters long. The process is a continuous extrusion. First, the pre-stressing strands are pulled taut and locked into place at each end of the bed. These high-tensile steel wires are tensioned to about 75% of their ultimate strength. This pre-tensioning is what gives hollow core planks their ability to span long distances without sagging. Next, a specialized machine called an extruder or a slipformer moves down the bed. This is the heart of the operation. It's a complex machine that does three things simultaneously. It vibrates the concrete to remove air bubbles, it shapes the concrete into the precise profile of the slab complete with the hollow cores, and it finishes the top surface to a smooth texture. The hollow cores aren't just there to save weight. They reduce the amount of concrete used by up to 50%, making the planks incredibly lightweight and efficient, while also providing a natural conduit for electrical and plumbing services. As soon as a section of slab is extruded, the next phase begins immediately: accelerated curing. Time is money in a factory, and waiting 28 days for concrete to cure is not an option. To gain strength in hours, not weeks, the entire casting bed is turned into a giant steam chamber. Plastic sheets or enclosures are placed over the freshly extruded planks, and steam is pumped in, raising the ambient temperature to around 60 to 70 degrees Celsius. This heat accelerates the chemical reaction of hydration, allowing the concrete to reach about 75% of its design strength in just 12 to 18 hours. This rapid curing is what makes mass production feasible, allowing the same casting bed to be used every single day. Once the concrete has reached its required stripping strength, the pre-stressing strands are released from their anchorages. The force in the strands transfers into the concrete, compressing it and giving it its signature strength and crack resistance. With the plank now a solid, structural unit, the demolding and handling process begins. Overhead bridge cranes, equipped with special lifting spreader beams that connect to the pre-placed inserts, gently lift the plank from the casting bed. The long, continuous slab is then moved to a cutting station, where diamond-tipped saws cut it to the specific lengths required by the project drawings. This is where the efficiency is breathtaking. From one long, continuous pour, the factory can produce dozens of custom-length planks for multiple different projects. After cutting, the planks are stored in the yard to continue curing and gain their full 28-day strength before being loaded onto specially designed trailers for transport to the construction site. The final phase is delivery and installation, where the factory efficiency translates directly to site speed. The precast planks arrive on site just in time, sequenced for installation. The crane operator simply lifts each plank from the truck, and the site crew guides it into position on the supporting beams or walls. No formwork, no waiting for concrete to set, no on-site stripping. The crew bolts the planks down, and the floor is structurally complete almost instantly. The following trades can often begin work on the very next level down. When compared to the week or more it can take to strip, shore, and pour a traditional cast-in-place floor, the precast method can cut the per-floor cycle time by more than half. This is the ultimate payoff of mass production, transforming a critical path activity into a rapid, predictable, and safe assembly process. In conclusion, the mass production of concrete floors isn't just about making concrete faster. It's about re-engineering the entire construction process. By moving the messy, variable work of concrete placement into a controlled factory environment, we achieve unparalleled levels of quality, speed, and efficiency. The humble hollow core plank, a product of precision engineering, robotic extrusion, and accelerated science, is a key reason why our cities can rise so quickly today. It represents a fundamental shift from construction as a craft-based site activity to construction as a manufacturing and logistics operation. Now I want to hear from you. Have you worked with precast concrete floors? What was the biggest advantage or challenge you experienced on site? Let me know in the comments below. If this look inside the factory has been enlightening, please give this video a like and subscribe for more content that breaks down the engineering behind modern construction.